Let's look at this next idea about building a table based off of inputs and outputs. So let's go through and let's go ahead and fill in the table about what happens when you use this equation and you use these numbers for inputs. So let's start off here and let's go put these numbers in place of x. So here I'm going to have 2 times x, but instead of x, I'm going to put -3, add 1. So 2 times -3 is -6, add 1 is -5. So when I put the number -3 in for x, I get out a y value of -5. This means that if I graph this equation, I will see the ordered pair -3, -5 on my graph. So let's go put this in, -3, -5 graph. All right, let's make an input of -2. So 2 times -2, add 1. So 2 times -2 is -4. -4 add 1 is -3. So there's a point on this graph at -2, -3. All right, 2 times -1, add 1. So -2 add 1 is -1. And some of you may use your calculator to get these values, and that's fine. So -1, -1. And we'll put 0 for the input, add 1. So 2 times 0 is 0. 0 add 1 is 1. So 0, 1 is on our graph. Let's put 1 for x. 2 times 1, 2 plus 1 is 3. So we have the point 1, 3 on our graph. Let's put 2 in for x. So 2 times 2 is 4. 4 add 1 is 5. So when the input is 2, the output is 5. And then the last point, the value we're going to put in for x is 3, 7. So 3, 7. So if you look at the graph, what I notice is that this is a function because the vertical line test works at every single point. No matter what I put in for x, I get a y value, and none of them are stacked on top of each other. So this passes the vertical line test. Also, if you look at the input values, none of my input values are repeating. So this means that this is a function. So for every input, there's exactly one output. So we're going to introduce the idea of function notation. And in function notation, you have to know it's a function. And when you do know it's a function, you can use f of x instead of the letter y. So really, my ordered pairs are an input, and then f of x is my output. And we're going to explore this idea with evaluating and graphing in just a moment.